Hi guys, it's Mrs. Millison. Let's go over the check your understanding on page 159. Okay, is there a relationship between the amount of sugar in grams and the number of calories in movie theater candy? Here's the data from a sample of 12 types of candy. Okay, yum. Where are those? Peanut M&M's, the best. Okay, identify the explanatory and response variables. Okay, explanatory and response variables. Explanatory is what we use to predict the response. Okay, so it looks like we're going to use sugar to predict calories. Okay, so my explanatory is the sugar in grams, of course, right? And my response is the number of calories. Okay, so we use the explanatory. Oh, you can't even see that. We use the explanatory to predict the response. Okay, so we're going to use sugar to predict calories. Okay, so that's how we know. Okay, number 2 says, make a scatter plot to display the relationship between the amount of sugar and the number of calories. Okay, so for my scatter plot, my explanatory is always my X and my response is always my Y. So if I look at my table, let's figure out what the smallest and what the range of X's have to be. So sugar, it looks like 44 is my lowest and 136. So I got to go from 44 to 136. And then my calorie or my Y's, 350 seems to be my smallest calories, and 790 seems to be my highest. Okay, so on my x-axis, I need to go from roughly 40 to 140, or from 40 to 140, and then my y-axis has to go from about 350 to 800, okay? You don't have to start your scatter plots at 0, okay, because that'll just have a lot of empty space on the graph. So you can start your x and y axis for a scatter plot at the lowest possible value. Okay, I think for the y, I'm going to go by hundreds from 3 to 800. So let's see, 800, 700, 6, 5, 4, and 3. Okay. So this is going to be my y-axis. Put my tick marks here. And then so this is my calories, right? And then for my sugar, what did I say? From 40 to 140. And I'll go by tens. Okay, so 40, 50. And this is sugar in grams. Okay, all right, let's plot away. All right, how am I gonna do so you can see both? All right, I think you can see both. Okay, Butterfingers, 45 and 450. So 45 and 450, 107 and 570, 62 and 480, 44 and 370, 79 and 790, 60 and 420, 61 and 580, 87 and 450, 92 and 490, 136. Boy, that's a lot of sugar. Sweet tarts. 136 and 680, 59 and 460, and 48 and 350. Okay, there's my scatter plot. Can you see those dots? I'd zoom in, but then I'm going to mess up my whole camera thing. Okay, so there's my lovely scatter plot. All right, let's describe. So when we describe a scatter plot, okay, we're just talking about three main things. We're going to talk about strength, direction, and form. And then I always say anything unusual, any unusual observations. Okay, so let's kind of work backwards. We're always looking for a linear form. Okay, so we're going to describe the linear form. The direction is definitely positive, it's going up. And then the strength of that positive linear form. I think it's, moderately strong. It's not like a super straight line, but when I look at it, my eye does go up. So I'm going to say moderately strong, positive, linear relationship between, and then list the variables. Okay, so there's a moderately strong positive linear relationship between sugar content and calories in movie theater candy, right? Okay, I should put a there is. There is a moderately strong positive linear relationship between sugar content and calories in movie theater candy. Okay, is there anything unusual? I think this guy is unusual. So what was that? 79 and something. 79, 70. So that's the peanut M&Ms. Okay, so I'm looking back on the table here. 79 and 790 is the peanut M&Ms. So I would say the peanut M&Ms with 79 grams of sugar and 790 calories, is an unusual observation. An unusual observation. And we'll get more detailed into unusual observations later. Okay, I think that's it for this one. So I hope that was helpful, and I shall see you next time.